get the book, register to SPUG, Yuva and Yuri. Well, I would like to ask to register for 2 more account after that letter. For a moment, is there anyone want to discuss about the complexity of merge sort? Or for student, are you forget with the task? No one? Okay. If there is no one want to share the code or want to explain, or is there anyone want to say something? So okay, if there is
Sir?
Okay, Dewanga.
Yeah, the complexity of the merge sort, is it?
Yes, it is.
The complexity, well,
actually you can explain it in bahasa if you want.
Serahlah. Oke. Maybe bahasa nggak apa-apa. Gini, dari merge sortnya itu kan ini mungkin baru sebagian saja, belum sepenuhnya. Kan merge sort kan itu awalnya dibagi 2 dulu awalnya, pertama dulu. Terus kan ini jenis merge sortnya ini kayak jadi lebih kecil gitu, namanya di buku yang dibaca itu divide and conquer namanya, divide and conquer. Itu nanti bentuknya seperti rekursi, makanya kemarin itu agak kesulitan mencari kompleksitasnya kemarin sebelum baca bukunya itu. Terus dihitung lagi kecil-kecil kan, itu kan dibagi 2 terus-menerus sampai menjadi satu bagian gitu, satu bagian terus disusun mana yang lebih kecil, mana yang lebih besar, terus diurutkan ke atas terus, ke atas digabung terus, berarti sepertinya ada lognya di sini. Log,
yes, based on the book.
Theta log berapa itu yang agak yang
log 2.
Sorry?
Log 2.
Is log 2. Log 2n, kalau tidak salah. Theta log 2n. Karena dibagi 2 terus-menerus, terus diangkat terus sampai menjadi urut.
Okay. That's all. And is there anything you want to share, maybe? Test. Hello, Dewanga.
Yes,
that's
sir.
all. That's all for the explanation. Or do you have some, maybe you are already create a draft or like presentation, small presentation or small calculation based on something?
No, I don't think so. Not in PPT, not at least.
Okay, never mind. Thank you very much. Thank you very much, Dewanga, for your activeness. Okay, I will give you 1 point for this session. Thank you. Anyone else want to explain something? No one? Okay, if there is no.
Saya Jonathan Leonardo. Iya, saya Jonathan Leonardo, Pak. Mau coba ngasih pendapat kenapa bisa dapat merge sort itu bisa dapat log n.
Ya.
Itu kalau yang saya baca-baca kemarin, kalau nggak salah kan merge sort itu dibagi jadi 3 tahap, itu ada divide, conquer, sama combine.
Yes.
Nah, pada bagian divide-nya itu dia memakan waktu atau kompleksitasnya itu O1 atau constant time. Karena dia cuma menghitung bagian dari array tengahnya doang, nilai tengahnya. Misalnya kalau panjang array-nya 8, dia dapat nilai 4, yaitu nilai konstannya 1. O1 makanya buat divide-nya. Sedangkan kalau untuk conquer-nya sort itu dia kayak dari misalnya kita anggap merge sort itu TN, lambangnya. Berarti kalau kita melakukan conquer itu akan tercipta 2 proses TN tapi dengan N-nya itu dibagi 2. Nah, itu yang harus dihitung. Dan juga sedangkan kalau untuk combine-nya itu memakan waktu ON atau kompleksitas ON dari sesuai banyaknya elemen array yang ada. Dari situ setahu saya dasarnya.
Oke.
Baru dari situ nanti bisa dikembangkan. Akhirnya proses divide sama combine-nya itu bisa disatukan karena kompleksitas O1 sama ON itu O1 itu kan termasuk low term apa gitu saya bacanya. Jadi bisa dihilangkan dan masuk ON aja. Jadi kita dapat rumus 2Tn/2 plus ON. Dari ON itu baru kita bisa ngebuat tree-nya. Dari tree-nya itu didapatlah perhitungan kalau setiap level dari tree-nya itu menghasilkan kompleksitas constant time dikali banyaknya array, banyaknya elemen pada array tersebut. Dari situ akhirnya didapat kesimpulan bahwa sebenarnya kompleksitas dari merge sort itu banyaknya level yang tercipta pada tree dari banyaknya array tersebut dikali constant time dikali banyaknya array.
Oke.
Akhirnya dapat rumusnya itu N2 log N. Gitu sih Pak, kalau nggak salah.
Okay, thank you, Jonathan, for your explanation. Well, actually, it's not wrong, but it's for me it's not complete, but it's okay because you have. Well, I think you have already take the course of data structure. Maybe there is some divide and conquer, but it's not too deep for that. For the calculation of complexity, so never mind. We will discuss it after. How we get yes, actually in merge sort there are it implements divide and conquer in this kind of sort. It use 3 steps. The first one is dividing, conquer, and combine. And for each computation, for each step there is a computation. And how we get, actually the most interesting is how we get log n or log to n. That's we can use the mathematical, well, not so complex mathematical foundation or calculation, but we can use a mathematical approach to see the complexity. Actually, you can move from, for example, 2 power n, and then you convert, etc. Well, I will explain it later in the chapter of divide and conquer. But for a moment, thank you very much for Dewangga and Jonathan for your activeness. Okay, thank you. So let us start the course. Okay. Actually, we will continue the same course as last week, because it's still in getting start. We are still in the getting start, but we are already finishing the 2.3 designing algorithms. So we move to the case studies. In this case, I use the same presentation as Mr. Sulaiman, and normally Mr. Subakti also. So we return with our understanding about data structure and algorithm. What is algorithm? In short, algorithm is like outline the essence of computational procedure, step-by-step instruction. So that's why you have to create, maybe in the programming 101, you have to create like flow chart, or you have to create you have to calculate or simulate with step-by-step for the procedure. That's the algorithm. Then what is program? So algorithm is not the same as program. Well, algorithm is a universal language or a universal thing. Program in general, it's split by or classified by the source code, which is the implementation of an algorithm in some programming language. Maybe you want to create for sorting, for example. You want to create a sorting algorithm, let's say insertion sort, but some people prefer to create it in C, some people prefer to create in C#, C++. then another one want to create in Java, etc. It doesn't matter. That's program. And the last one is data structure. Data structure is the higher level than program. It is the organization of data needed to solve the problem. So it's not only the implementation of algorithm, but it also consists of the organization of the data. What kind of organization, what kind of data, etc. Well, maybe in simple, we have one variable or an array, something like this. But more complex, we have vector or linked list, dynamic array, or if we see further, we will need maybe in graph problem, we will need like constructor, etc. We need adjacency list, etc. Normally, you have already got this course in data structure or dictionary, etc. Has list, etc. Okay, that's that data structure. Reminder from last week also. In data structure and algorithm design goals, the goals are correctness and efficiency. And for the implementation goals, which is the program source code implementation, robustness, adaptability, reusability. So we start with correctness and efficiency. Well, last week I already explained it. I explained it this one. The correctness is this is to make sure that your program give a correct output. Given an input, certain input, it will give this same output or consistent output all time. For example, if you want to create a program one-to-one, and the output has to give equal to 2, or if you want to merge one-to-one in text, it will be 11, or etc. If you want to create some another definition of the 1 plus 1. That's the correctness. Consistency over the time for all the given input. And then does the correct is sufficient? Well, basically yes, but in general, in practical use, it's not really it's not enough. You have to add another aspect, which is efficiency. Suppose you have a sorting algorithm. Well, there is a competition. Maybe there is a competition. You have a team and the other team, and your team create a sorting algorithm which use bubble sort. Well, it gives correct answer, but it takes like 2 hours, while another team it only takes like half an hour or 20 minutes to solve the problem with a similar answer. So the better is the efficient program. Just to make sure you create basically, firstly, you have to create the correctness followed by efficiency. But the most important is correctness first, then efficiency. And for implementation, for creating the source code, it has to be robust. What does it mean? It means that it can handle like a wide area, or it can handle various input and give the correct answer. Or given a certain limit or certain threshold, the lower like a lower bound and upper bound, the lowest value and the highest value, you can compute it within these values. And another one is adaptability. What does it mean? It means that, for example, you have you have an algorithm, but you need some sorting algorithm or something. It means that, adaptability in here is it's more like it can handle various type. Well, robustness is strong enough. Robustness is it gives a correct answer over the time. Adaptability, it gives from various condition. Give the correct answer from various condition. While reusability, your program can be used for another program. For example, you have already created the sorting algorithm and you want to use it, or you want to reuse it for another algorithm. That's reusability. That's the implementation of a data structure followed by the implementation goals. This is the same example as last week, but I didn't give a deep understanding for this, I think. Well, I did I give the explanation, but I think it's not based on this slide. For example, we need to create a sorting algorithm 2, 5, 4, 10, 7 sequence of number, and you have to permutate or you have to change the position so that it can give an order, an ascending order 2, 4, 5, 7, and 10 permutation of the sequence number. For the correctness, whatever the input, it will give the ascending order every time. So for any given input, the algorithm halts with the output B1 is less than B2, less than B3, or maybe not less than, but less or equal than B2, less or equal B3, etc. Well, for the running time, it depends on the number of elements, the length of the n. Last week we have already discussed it. How partially sorted they are. Last week I have shown the video also. Different condition of sorted, partially sorted of an array, and then the output, different output of running time. And the algorithm itself, it's the essential. Whether you use bubble sort, whether you use merge sort or insertion sort, quick sort, etc. We start with designing algorithms. Several techniques pattern for designing algorithm exist: incremental approach and divide and conquer. We have already discussed it last week. Well, incremental builds the solution one component at a time. Divide and conquer breaks original problem into several smaller instances of the same problem, like merge sorts. Given same, given an array, a merge sort will break the array into two sub array, and then smaller until the last one, or we can call it atomization. This is the pseudocode convention. I already asked you last week. Normally, you have already got it from Programming 101, the first semester. This is how we use for, like for g equal to 2 to a dot length. It means that like n. Then you calculate, and this is the comment, etc. This for while also. You see in here there is no, how to say, brackets. We have brackets over here, and closing the wave bracket. It's only tab, using tab. If you are familiar with Python, actually Python implement this kind of approach for grouping the source code. You don't need to use brackets or with curly brackets, but you can use only tab. That's why tabs matter or space matter in Python. You see in while a more than 0 and ai more than key, then it will recalculate again. It will do the iteration. That's how we write the pseudocode. And this is last week I asked you SPUG, UFA online chats, and URI online chats. But actually, sorry, because normally I rarely use eolim. But in this case, I would like to ask you to register to eolim.com. It's faster because the next problem we will use this tool also. And also, I would like to ask you, maybe if you want to try, because 4 of these sites, online chat sites, based on in English language. But if you want to try in Indonesian language, you can use TLX Talkie. Let me show you the TLX Talkie. This is the TLX Talkie. It's very interesting. So you can see over here, you can follow the course, pemrograman dasar and pemrograman kompetitif dasar. Well, this is for the programming 101, and this is for our case. In this case, you will have several several categories, like the introduction, mathematical discrete, etc., searching and sorting, brute force, event conquer, greedy, dynamic, structure, data structure, etc. Well, I create I create a new account for this course, so that you saw I still zero all. In this case, you can see over here, if you click, for example, perkenalan pemrograman kompetitif, you can click the materi perkenalan. It's in Indonesia. Short explanation. And in here you have several problems. As you can see, seleksi Olimpiade, it's in Indonesia, and the level of the difficulty will increase over here. So AB, normally AB are the easiest problems, and CD is quite well medium, and then there are E and F also. Let me show you where is the problems. Yes, E, F, etc. In general, but not always. So you can register to TLX-Toki. Let me share the chat. TLX-Toki and Olim. Because I will give you the assignment for this one. Okay, let us continue. So we start with ad hoc algorithm. What is ad hoc algorithm? If you have already opened URI online chats, you will see there is a category called ad hoc algorithm. Over here, I think. Problems, this one, ad hoc. There is ad hoc, string, data structure, libraries, etc. Which literally means for this. Ad hoc in Latin phrase, it generally signifies a solution designed for a specific problem or task. As you remember previously, I explained about the reusability. Sometimes there is an algorithm which couldn't be modified or couldn't be applied for several problems. It only suitable for a certain or for one problem only. That kinds of problem or that kinds of algorithm, we call it ad hoc algorithm. We design for specific problem or task, or generalizable, sorry, and which cannot be adapted to other purposes. So it's specific. We start with this example. A only 10,281. You can access it over here. It will be your first assignment, but I will give you some brief explanation. So here is the problem. Let me open this one. Here is the problem. The problem called column, given n columns of cubes. This one column of cube. The I has height AI. This is the height A. Find the smallest number of colors sufficient to color all the cubes so that all substrings and columns have different colors. Note that the substring is a horizontal sequence of cube in a row that is without gaps, which is this one, and this one is connected. So you have to create like if you are familiar with Sudoku, you have to assign the same. Yeah, No, you have to assign different values from 1 to 9, and it has to be different from each column and each row. So it has the similar case in this problem. You have to color for each cube differently between between other cubes in the same column or in the same rows. For example, this is red, then there is no possibility that you need to color the other as red also, as well over here, the row, the column and the row. So maybe this is blue, yellow, green, or blue, yellow, green, etc. But not red, because red is occupied over here. And this is the limit. This is the limit. The first line contains one integer n. This is the example. Yes, this is the one of the possible solution. The first one is n, the number of columns. In this case, there are 4, 1, 2, 3, and 4. Then the second line contains n integers a1, a2, etc. until an. The height of the ith column, 1, 2 until n. In this case, this is a for the first one is 6, 1, 2, 3, 4, 5, 6. And then this is 5, and then this is 2, and then this is 4. And the output is the number of minimum print one number, the minimum number of colors required to paint all cubes so that all substring and columns have different colors. So this is the first problem. Based on your current understanding or this brief explanation, do you have any idea how many, what is the minimum number of colors required to paint all cubes? Is there anyone want to say want to speak or give opinion? Yes, Thomas, can you repeat it again?
Untuk mencari the minimum number of color required, I think just search for the largest column. Just like this is sini ada 6, terus 5, 2, 4. Pasti untuk mencari untuk mencari minimum numbernya ya tinggal ikuti kotak kolom yang paling banyak, yaitu 6.
Okay, thank you, Thomas. Let me save your point first. Where is it? Thomas. Okay, thank you. Well, your answer is halfly correct. It's halfly correct. There is another way, there is another hole. Is there another student want to explain? Okay, Nabil. Yes. Okay. Oh yeah. Yeah. Thank you, Nabil. I got your answer, and that's the correct answer actually. Yes. Thank you, Nabil. Let me save you. Well, Nabil. Where are you?
86.
Oh, okay. Okay. Thank you. So, thank you, Thomas and Nabil. Yes, the maximum number is you get the whether you calculate the maximum you have to compare the maximum number of n or a. So if the number of a is the maximum number of a is less than the number of n, the number of the columns, then you have only you have to consider n only. But in another way, if the a is highest, the maximum number of a is higher than number of n, then you have to consider a only, the maximum number of a only. In this case, the highest columns is 6, while the number of columns is 4. So we consider only the highest column, which is 6. So you compare this value and this value. That's the correct answer. Easy peasy squeezy. So it's easy, right? That's the first assignment. So let me return to the slide. Yes, this is the example. And for this first assignment, I'd like to ask you, honestly, if you're looking for if you're looking from the answer from other classes, maybe Mr. Subakti or Mr. Sulaiman shares their code. But for me, I don't want to share the code. Well, the code originally from Mr. Sulaiman. I don't want to share the code because I would like to ask you to submit to register to EOLIM and then followed by submitting in this problem, because this is the easy one. So normally you can do it faster. This is the first assignment.
Izin bertanya, Pak.
Yes.
Bahasa pemrogramannya bebas atau ada tertentu?
Yes, for language programming, I prefer using C++ or C.
Baik, terima kasih, Pak.
Thank you, Clifton, for the reminder. Okay. There another question for this kind of assignment? Starting from now and until following at the end of the course, I will use this kind of evaluation for the weekly assignment. So whether you'll be asked to submit in here or in URI, on SPOG, or maybe over here.
Permisi, Pak.
Yes.
Saya mau nanya untuk kan kita mengupload ke EOLIM-nya. Nah, untuk mengumpulkan tugas kita itu nanti kita mengumpulkan link ke submission kita atau bagaimana, Pak?
Yes, I will explain it later at the end of the course. So just to make sure that you follow the course at the end. Thank you for your reminder. Okay, that's the first case study, and then we continue with the second case study. This is the second case study, unique numbers. It's from SPOG. Do I have, I think I have, yes, this one. This is, I will share the code. Well, actually, if you are curious with my account, maybe, actually, I don't use my real account. with the same as I explained. So that's why it's still empty. Like from here, it's still empty. My account is still clean and empty. By doing this, while you can. So I will restart it again. So if there is any problem, I'll make sure that it can be done during the class. Okay, this is the second problem, unique numbers. This is from SPOG. Uncursor, getting bored in class, thinks of something to pass his time. He writes all the numbers from 0 to n-1 and then does key operations on these numbers. The operation are two types. Actually, this is the first one. There is each line there is one pair of number. The first one is the type of the operation, whether 0 or 1, and the x. This is the variable. Well, we will replace for the output. We'll replace its number I by I is the sequence from 0, 1, 2, 3, etc. I, etc. Until n-1. Replace its number I by I. If the operation is 0, then you have to apply this kind of operation, I plus x modulo n. If the code of the operation is 1, you have to reply by this one, I multiplied by x modulo n. And now he wants to know how many unique numbers are there after each such operation and has asked for your help. And remember that this one, it's important to notice. Its operation is done on the numbers that we get after the previous operation and not on the original. I will explain later from the representation. The input is this one. The first line contains n. The second line contains k, the number of operation, and the last one contains it's of the next k lines contains two integer p and x. P is the code of operation and x is this variable. Output k length. It contains how many unique numbers are left. You see over here, they don't ask the answer for a certain problem. Well, in here, in columns, they ask. Well, actually, there are several steps or several difficulties in this kind of problem. For example, the easiest one is asking the solution. Like for this one, asking the minimal solution. Whether how you combine this color, etc., it doesn't matter. You just need to answer the smallest or minimum value, minimum solution. Or the second level is a little bit complicated. You will be asked the possible solution and the number of possible solution. Like for this one, red, it can be placed over here, etc. until the end. Maybe it's not only one solution, but there are also several solutions, 2, 3, 5, etc. N solution, X solution, sorry. And the last one, it's the most complicated, is you have to print all kind of solution. Why it's more complicated than the second one? Because the second one, you can, in certain case, you can calculate the possible solution without calculating the solution itself. So you will have like, oh, this it will give like 5 combination or combination 5 and 2, etc. Permutation of 5 and 4, etc. But for the third one, you have to give the answer. Give the all possible solution. For example, the question, something like that, output. Normally for that kind of problem, it's more difficult than just finding one possible solution. Okay, we continue to this one. In this case, they will ask how many unique numbers are left, not what is the answer of this I number, etc. So it's a little bit complicated than the first one, but it's still doable. in half an hour. Well, half an hour, well, it depends. Sorry. And this is the constraint. From the end, as you can see, first one here, 30. So we have from 0, 1, 2, 3, 4 until 29 because n minus 1. Then second line contains k, the number of operations. So we have three cases. This one, the first one, second one, and third one. And each line, the next line is the cases. So the first column is the code of the operation 10, 10, 01, etc. The second one is the x variable. And this is the constraint for n 1 between 1 until 10 power 8. So like how many? 1,000. 100 million. Yeah, I think 100 millions. Sorry, 100 millions values. So just make sure that you are able to cover this range of data. And the k between 1 and 20, the p is 0 or 1. X between 0 until similar to n 10 power 8. 100 millions. So this is the output, the sample of the output. And I will give you the explanation. Or is there anyone want to explain something? How can we get from this input 1A, then we get 15? Is there anyone want to say something and give an opinion? Well, and semi-random opinion. How you got this number? How you will get this number? Okay, Nabil, it's fine. That's great. Yes, that's the core of the solution. Okay, that's good. That's enough. You don't need to continue. So, okay, thank you, Nabil. FBB, or GCD in English. Okay, that's one possible way to answer the question. Or maybe so far the most efficient way to answer the question.
Excuse me, sir.
Yes.
I want to ask something.
Yeah.
Can you scroll above a bit the spots? One more. What is the number I?
The number I will show you this one with this. Actually, there is sample of answer. Well, there is a code also, but I won't give you the code. This is the explanation. This one. Let's say we have n equal to 30. I didn't record. It's fine. N equal to 30, and so we have from 0 until 29. N is 30, and this is the I. I starting from 0 to 29. Is it clear, Dewanga?
Yes,
so,
yes, sir. Yes.
So let's say we start with this one, the operation 1, 0, 1, and then this is 8. Actually, I create sample. Well, I create solution in Excel, so you can easily understanding. This is you can interpret it and change it into algorithm. Then you can solve the problem. And this is the X. It's 8, 3, and 12 based on this problem. 8, 3, and 12. So we start with this one. 0. How can we get 0 for here? We will see firstly whether this operation is 0 or 1. If it's 1, then the computation is if one I multiplied by X modulo n, this one. But if this is 0, then the computation will be I plus X modulo n. And then we continue until the end. After that, we calculate the unique numbers. The unique numbers, if you can see over here, you can see it's like 2. I mean, is there any 3? Well, we have 0. 2. Is there any 3? No, there is no 3. There is 4, and there is 6, etc. Until the end. Well, maybe what's the highest number? I think the highest number is 28. And the total number of this one, if we calculate 1, 2, 3, 4, etc., it will be 15. So that's how you get the answer. After that, we continue not from beginning. That's the note of this one. Its operation is done on the number that we get after the previous operation, and not what on the original. So this is the original, but this is the current state for the second case. So we start to calculate from here 0, like 0, 0. So or we start from here 8. How we can get 11? So we see it's 0. So 1 plus 3 is 4. 4 modulo with 0, yes. Plus 3 equal to 4 modulo n. Wait, I think there is a mistake. It's not 11 actually. Oh yeah. So actually, I think there is a mistake. I put the wrong modulo. Let me check. But it gives the correct answer. That's why sometimes you got the wrong answer. Well, wrong solution, but overall you got the correct global answer. Let me check over here. Sorry, let's see modulo. For modulo 30, is 4 normally. So I put the wrong order over here. Let me change. No. Sorry. Yeah, that's my fault. Yes, this is correct actually. Sorry, it's correct. It's not 1. Sorry, the original is 1, but we use the current position is 8. 8 plus 3 modulo 30. So it's 11, and then etc. until the end. So that's why at the end it's 15. So this formula is correct. And then the last one is 1, and the x is 12. Let's for example 19 multiplied by 12. How much? Well, let us start with 5 first. 5 multiplied by 12, it's 60. 60 modulo 30, it's 0, because it left 0. So that's how you get the answer. 15, 15, and 5. Is it clear for you? And this is another example. For example, this one, suppose the n is equal to 15, and 1, 2, etc. This one. So this is the source code that I copy. No, the Excel formula that I copy paste in the formula. So for the assignment, I will explain it first, because based on this one. I would like to ask you not only solve this one, submit and accepted. That's not the core, because some problem or a lot of problem set like this, you will find solution on the internet, and it's inevitable. The most important way that is you have to understand and you have to create the most efficient way, because sometimes the code existing the code from internet, it's only finding the correct aspect, not the efficiency. So you have to find the efficient solution. So for the assignment, normally from last semester, I would like to ask the student to create a PowerPoint, which give, for example, give your name and the title, and then the screenshot of the problem and the code of the problem with and also the link of the problem. Then followed by the representation of the solution, or how, for example, this one, there is a sample example of this one, input and output, how we get 15, etc. So you have to explain, like you have to give the representation or something like this. Then followed, you have to write the pseudocode as the algorithm, how you solve this problem. Then at the end, then after that, you give your source code, real source code, whether in C, C++. And then after that, you give the screenshot of the accepted. And if you are not accepted, well, if it's wrong answer, etc., just show all the record that you have submit. Maybe sometime, for example, Nabil will accept in one try. How normally I ask students to submit the assignment. Is it clear from the assignment how you create it? So you just submit the PowerPoint, which contains several elements that I explained previously. Is there any question for the assignment? No? Putu, is it clear for you how to submit the problem?
It's pretty clear. So.
Okay. That's good. And then I'd like to give you like 20 minutes to try this code. Try to implement, try to register this one and try to submit your solution. After 15 or 20 minutes, we will discuss it together. So try to pass this one, columns, and this one, unique numbers. Okay. We'll back to discuss it in 15 minutes. 6. Great. 7. Okay. Only the first one, not the second one. Okay, thank you. So that's the first problem. And the second problem. Anyone is ready, success to submit? Nabil, you are ready, success to submit? Oh, that's good. And Putu, how can I call you? Putu, Ananda, Satria, or Adi?
You can call me Putu or Ananda.
Okay, Ananda. Yes, well, I will call you the first name, Putu. Okay, Putu, you already submit the second one also? Yes?
No, not yet, sir. I'm currently working on it.
Okay, that's good. Okay. For others, well, I will give you until 2.20, and then we continue to the next discussion. Let me know if you have any problem, or you are still confused with the question, etc. Bothering you, etc. Let me know. line. This is like the name of the country or the area. And cities are located on a straight line and numbered with integer from 1 to n. Remember 1, 2, 3, etc. Each city is characterized by a certain value xi, the city coordinate. This is the characterization. The distance between the cities with number I and g is equal to xi minus xg. Cossacks want to know the minimum distance he will have to travel when traveling through Potokolandia, provided that he must visit each city at least once and complete the journey in the city where he started. So, want to know the minimum distance he will have to travel when traveling through Potokolandia, provided that he must visit each city at least once. So it's possible maybe more than one, and complete the journey in the city where he started. So it's like returning to the starting point. It's like it's kind of traveling salesman problem. Your task is to find the minimum length of the route, provided the city where the journey starts and the route remains at your discretion. The first line contains one integer n. I think this is the number of cities. The second line contains integer xy, x1, x2 until xn. This is x the coordinate. And print one integer, the minimum length of the route Cossacks use. In this one, 1 to 4, maybe we can try to illustrate something like this. Or is there anyone want to explain? Well, given the input 2, the number of city 2, and the input 2 cities, the coordinate or the position, and then this is the output. I will give you like 5 minutes and let us discuss. Maybe anyone want to explain the possible or the representation or design solution, whatever. If you want to give the opinion about the problem, I will prepare it also. So, anyone want to explain briefly?
Excuse me, sir.
Okay, Dewanga. Okay. Wait. Is there any other person except Dewanga, Nabil, Putu, and someone
Izin
else?
menjawab, Pak. Coba menjawab.
Yes, Clifton. Okay.
Kalau menurut saya itu kan inputnya ada N. Nah, terus semua inputnya itu di sorting gitu, Pak.
Ya, oke.
Jadi mulai dari yang kecil, terus ke ujung, terus perlahan-lahan balik ke paling kecil lagi.
Oke. That's all? Okay.
Iya, Pak.
Okay, thank you, Clifton. You're halfly correct, but it's good starting. It's good starting point. Is there anyone want to give the more efficient solution maybe, or another point of view? If not, well, Dewanga, you can say if you want. If you want to say something. Hello, Dewanga. That's Dewanga. You want to give your opinion?
I'm sorry, sir. What was that?
You want to give your opinion, your previously opinion?
Oh yes, about the journey.
Yeah.
Well, there's the number of city and the coordinates.
Okay.
Then that's the coordinate. Then it's depend on the way you type. That is, it's like the first example 1 and 4. The distance between 1 and 4 is 3. Then you're supposed to go back at the first city or spot.
Okay.
3 plus 3 equals 6. Well, that's it.
Okay, thank you, Dewanga. Yes, that's the correct solution. Well, it's similar to Clifton, but it's so I will show. Wait, let me check you 2 points in Clifton. Okay, it's already 1. So this is the simple explanation. This one, it's like the representation of Clifton that you start with starting city, then you find the maximum, then you return it again. If we calculate one by one, we will get the number of 6. As well as in the second case, this one, 1, 3, 1. So actually it's 1, 3, and return to 1 again. So only 4 step. And how can we get the most, if we calculate something like this, it's not efficient because we need to iteration 1 plus 1 plus 1, etc. But we can calculate it more efficient and simpler by doing this one. So we just calculate the number of the minimum, the maximum minus the minimum multiply by 2 because it's how to say in English, sorry, algorithm in French. In bahasa it's pulang pergi. So going and back again. So that's how we get 4 and 6 over here. It's simple, right? So you just give like if it's 4, it's 6, and what if this is by like the minimum? So the key is we have to find the minimum city. But sir, if for example, if there is a case like this, we have to go to for example 3, starting with 3, and then let's say we have 1, 2, 3, 4, 5. Let me write like this: 6, 7, 8, Yes, I think that's it. Now, example. So if we start with maybe not 1 but 4, so we have to follow like 4. What? In this case, you see, we don't need to visit in certain corresponding order, and well, in certain order like ascending or etc. The statement is that we have to visit it at least once. So we start with starting point. Your task is to find the minimum length of route provided the city where the journey starts and the routes remain at your discretion. Let's say maybe if there is any possibility something like this, and then 6, and then we return to 2 and then 8. Then how many route we take? We have to take 1, 2, or maybe we return to, or going back over here. In this case, I think, well, one minimum length of cosine view. You can try. Well, you can try it. But actually, with this code is actually submitted and it's correct. But you can try if you want to solve like this. Like you want to visit this one. If we consider like this, it will be like how many? So it's like 1, 2, 3. It's 12. It will be 12. But what if we consider from the minimum 2 until 8? It's the same. So as you can see, it's same. It's 12. Yeah, that's okay, because this one can put it over here. So it will be the same. Whether you start from the smallest index or coordinate of the city, or you start with the highest, or you start between them, it will be the same. Okay, that's for the question. The third question. Oh, this is the code. That's great. So I think that's okay. That's the case study. Do you have any question? If not, I will create an assignment. This is an assignment. So you have to create. You have to solve this one. No, this 3. So the first one we have already discussed. The second one and the last one, this the number of the city of journey. All the tasks you report. Your report is written in PowerPoint. In PowerPoint, 3 problems combined into one PowerPoint, which contains for each link or screenshot of the problem, design a solution, explanation, and illustration if it's possible. If not, it's never mind. You can illustrate it through the Excel, something like this, the table, and pseudocode and source code. Pseudocode, source code, and submission status. Whether at the end, like next week, until next week, you couldn't, or you are not success to accept all 3 problems, never mind, just submit it. Submit it before 24 March 00. Because I would like to see your courage, your effort to solve this problem. And the most important that I couldn't guarantee to see all of your tasks because it will be helped by the assistant. But at least please don't copy paste your friend's homework. If you copy paste your friend's homework and we notice it, we'll give you 0 directly without hesitation. For both of you, because normally we don't know which one copied which one, so we'll give 0 for all similar answer. Okay, let me save and return to the course. Then after that, we'll continue the theoretical foundation with the growth of function. Is there any question for the case studies? Or is it clear for you? Okay, if there is no if there is no voice, then I suppose it's clear for you. So we continue with the third chapter, which is growth of function. What is growth of function? The order of growth of the running time of an algorithm defined in chapter 2 we have already discussed last week. Gives a simple characterization of algorithm efficiency and also allows us to compare the relative performance alternative algorithms. Like, for example, we have several kind of sorting algorithms. We are able, or it allows us to compare the order of growth of running time. Allows us to compare which one's more complicated, which one's more complex, or needs the more running time than others, etc. Once the input size n becomes large enough, merge sort, for example, with its n log n, worst case running time with insertion sort was worst case running time is n squared. Also, we can sometimes determine the exact running time of an algorithm as we did for insertion sort in chapter 2. So in chapter 2, as we can see, we can calculate the exact complexity or computation time for insertion sort. This one we through this calculation. Let's continue. While in certain case we couldn't do the exact, but we could do the least and the best case and the worst case, and we consider normally in worst case. Well, the exact actually it's not theta. Well, the exact is theta, but the worst case normally is big O, like I introduced last week, and the best case is big omega. Extrapolation is not usually worth. This is the important note. The extrapolation is not usually worth the effort of computing it. For large enough input, the multiplicative constant and lower order terms of exact running time are dominated by the effect of the input size itself. The effect of the input size itself. So it's the most important. Instead of considering the variable or a constant in when you calculate the complexity, the value of C, you can consider the most important is you have to consider the n, the size of the input itself. When we look at the input size large enough to make only order of growth running time relevant, we are studying asymptotic efficiency of algorithm. So this is the asymptotic notation or asymptotic efficiency of algorithm. If you saw, if you see right now, maybe this one, the growth of function, there is a asymptotic notation and there is standard notation common function. What is asymptotic actually? The general definition, asymptotic. Asymptotic method describing limiting behavior as an illustration, something like this. So value a curve arbitrarily closely or some sort of limit is taken, which is sometimes it's not the exact, but it's approximation. Yes, asymptote of something, etc. So that's why sometimes when you calculate limit in calculus, the course of whether calculus 1 or calculus 2 or basic physics 101, when you calculate the limit 1 to something, sometimes you will find the keyword of asymptotic. So it's similar, asymptotic efficiency of algorithm. We can estimate or we can find the nearest, like, well, a possible nearest answer by calculating the complexity based on the input size. That is, we are concerned with how the running time of an algorithm increases with the size of input in the limit. As the size of input increases without bound, usually an algorithm that asymptotically more efficient will be best choice for all, but very small input. This chapter gives several standard methods for simplifying asymptotic analysis of algorithm. Okay, we will analyze the algorithm in asymptotic ways. We then present several notation convention. So previously we used theta. Notation we use describe asymptotic running time of algorithm. Define this one, set of natural number. This is to describe the asymptotic running time. So it's whether in natural number, it means that in millisecond, etc. Such notation are convenient for describing the worst case running time function. Tn usually defined only on integer input size. So actually the value of n and small n, actually it's also in natural numbers. Student pattern well, because the number of indexes is always in natural. So the notation of real number of the restricted subset and natural number. We should make sure to understand the precise meaning of the notation so that when we abuse, we don't misuse it. This is well, it's the extension, but we'll continue over here. We will use asymptotic notation primarily to describe the running time of algorithm. When we wrote the insertion sort, worst case is theta n square. Asymptotic notation actually applies to function, however. We call characterize insertion sort worst case running time as actually this one, the precise computation time in the worst case for some constant A, B, and C. By writing the insertion sort, this one, we abstract away some details of this function. So by writing the computation time, running time like this and square, we don't consider or we ignore these constants A, B, and C, and also this constant, this value n, because we only take the most hardest way, not the most hardest. The first function that we were writing as this one. Case happen to characterize works and time of insertion. In this book, so we start with theta notation. Even when we use asymptotic way to apply the running time of an algorithm, we need to understand which running time we mean. Sometimes we are interested in the worst case running time in general. However, we wish to characterize running time no matter what the input. In other words, we often wish to make a blanket statement that covers all input, not just the worst case. Actually, this is important. Well, I don't know for the practical, like for enterprise purpose, but in the research purpose, it's important that you want to compute your, like, you create a new algorithm, for example, sorting, and the complexity is n log n. So What does it mean? It's the same worst case as merge sort, for example, or quick sort. But if you consider like, as you can see last week, we have several conditions like almost sorted, inverse, or randomly, or a certain pattern, etc. It will give a different running time. So that's why sometimes we need not only consider the worst case, but we consider the average case or the best case also. Well, that's why it's important in the most. I usually see it often in the paper or publication research paper, but in the enterprise case or in the enterprise case studies, well, it's rarely happen normally, because well, in the enterprise we normally we have to expect the worst and we have to prepare for the worst, and it's more complex than just one algorithm. It's combinational law of a lot of, like for example, system information. It's combination of several algorithms, starting from the easiest one until the most heaviest algorithm. Okay, we continue. We need to understand this one. We start with okay, theta notation. We found that the worst case running time in sensor set is theta and square. Let us define this notation means for a given function. We denote theta, the function g, and a set of function fn that exists positive constant c1, c2, and 0, such that this one c1 constants of gn and then this fn, it's less than c2 gn, etc. for all n more than or equal to n0. For example, in here, as you can see, there is some constant over here, c1, c2, and this is fn. Fn is between two of them. If we compute fn something, if it exists something like this, and we compute fn, then fn is theta gn. But if we compute something like this and gn something like this, then we can consider the complexity. Like this is a lower bound and upper bound. If we consider the upper bound, then we can consider using big O. Plus one, if we consider, for example, this one, Fn, this is the same. But after that, Gn, we consider this is the same. And this one, this is the upper bound, this is the lower bound, which is big omega. And 0 show the minimum possible value. Any greater value would also work. This one. Normally, and 0, it's the same value between theta, big O, and omega. As you can see over here, it's the same starting point. Two within constant factor. Over here, we write Fn Gn if there exists positive constant at 0, C1, and C2. Upper bound, if there are positive constant and 0 and C such that at n2, the right of n0, the value of Fn always lies on or below Cgn. So it means that this is the upper bound, we consider this one. But if the Fn is always higher or on the same line, maybe it's big omega. If there are positive constant n0 and c such that at n to the right of n0, the value of n always lies on or above Cgn. As we can see over here, actually, sorry. Can I use? No, I couldn't use this one, annotation. Actually, we can write something like this. It's equal to something like this. Complexity, in terms of running time or complexity, this is theta. Let's say this is theta. It's less than or equal to equal. Because always lies on or above. This one also is on or above. Okay, clear. Well, this one you can write, you can read it. So this is the difference between, wait, let me check. Oh, this one is big O and the last one is big omega. For this one, I don't think, you can try. It's a little bit complicated, I think, for you. I think it's easier if we write something like this. For example, for E equal to 2 n, for example. Then, for example, we have k plus I. Then we have if k modulo 10 equal to 0, then k equal to k plus 1, maybe. Do we need to use else? No. I think we start with this one. To make it simple to understand, for you to understand, this is 1. So the complexity, it's like this complexity will be whether big O n, and if we want to get precise computation, we can consider like this. This is, for example, n. And let me check. For this one is n minus 1. This one for the checking is n minus 1. And this one is this is the potential. It's also n minus 1 also the possibility. So the theta, the exact calculation will be how much n? Well, the theta is between two, the best case big omega. Let's say I will write omega. N is something like this. N plus n minus 1 or in this case let us make let me write it over here. I think it's easier. Control C. Wait, let me clear all drawings. Okay. For I to 1 to n, then for example k plus 1, if k, not this one, if k modulo 10 equal to 0, then this is how we write the pseudocode. Then, for example, like this, for G equal to 1 to K, let's say, for example, sum equal to K plus I, for example, like something like this. Sum plus I. So, or not by 1, maybe by I multiply by 3, for example. So to calculate the complexity, we will have n minus 1 over here, and n minus 1 also over here. And this one, the possibility is like K with the number of K's increasing. And this one, well, maybe like K minus 1. Sorry. Sometimes, in the best case, we don't need to calculate. Sorry. For the interruption, it's already okay. Sometimes we don't need to calculate. Sometimes because the number of there is a condition that this condition will never meet or will never reach this condition. So we don't need to calculate this one. So this is like the sum of these three is the omega. While there is a condition when we have to calculate all this it's under the end. And the complexity to calculate all of them are, let me write over here, and this is, let me make it as y, and this is what to say, this is the big O. So you see over here the complexity, whether the complexity is only this one, it's omega, the best case, or this one, the worst case. And where is theta? Theta is between omega and big O. Actually, sometimes it depends on the problem, and it's not the definition. It's not one linear statement like n plus n minus 1, etc. But it's theta. It's between this one and this one, so it's range. So that's why we call it asymptotic, not the exact value. Okay, that's the introduction of the asymptotic notation for big O, omega, and theta. Is there any question? I think it's already at 3.2. Is there any question so far? It's not clear. If there is no question, so with the rest of the time, we can finish the homework and let us discuss next week. Thank you for your attention, for your participation, activeness. Okay. Tetap jaga kesehatan, semoga segera divaksin, tetap ya semoga selalu sehat selalu keluarga. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore.